All right, you guys, let's go over this quiz review in time for our quiz tomorrow. Gosh, there's a lot of blank pages here. Okay, question one. Question one says, which of the following is not an asymptote of the rational function? So in order to do this, the first step is I'm going to need to factor the denominator. So I'm going to leave my numerator as 2x squared minus 15. I don't see a real easy way to factor that, so that'll just stay that way. And my denominator I can make into x. If I'm looking for two numbers that add up to be negative 2 and multiply to be negative 15, that's going to be x minus 5 parentheses times x plus 3. Okay, the reason I factored this is because now I can figure out my vertical asymptotes where x is equal to, so these are the vertical asymptotes, and there's going to be 2. Okay, so this is going to be what value for x would make the denominator 0, because that is where this function is never going to exist. So the first one is going to be positive 5, right? Because if I make this x positive 5, that becomes 0. And x2 is going to be negative 3, because if I make this negative 3, this one's going to be 0. And either one of those being 0 makes the entire denominator 0, which makes the equation explode at that point. Those become vertical asymptotes, right? Now, the third asymptote, the reason why there's just one, is that we need to figure out the horizontal asymptote. So if you guys still have questions about this, please go back and watch that video. It does a great job, much better than I did in class, of explaining how to find the horizontal asymptote. For this particular case, I will tell you, since the numerator and the denominator have both degree 2, right? There's a 2. Actually, I'm going to highlight so that we can see. There's a 2 there and a 2 there. It's the highest degree. Since both of them are degree 2, that, and then let's pick a different color, that coefficient, here it's 2, here it's 1, because we don't see it. If we just divide those coefficients, that becomes the horizontal asymptote, or where y does not exist, right? And so the horizontal asymptote, y does not exist at 2 over 1, or just 2. So we know that negative 3 is an asymptote. It's a vertical asymptote. We know 5 is also a vertical asymptote, and we know 2 is a horizontal asymptote. So that means that 1 is not an asymptote of this function, or that we know that the function exists at 1 is another way to say that, right? Question 2, which statement describes the right end behavior of the graph? So let's go ahead and let's go ahead and find the horizontal asymptote, and then I'm going to graph it and show you. So since these are both degree 1, the horizontal asymptote, I don't need to graph it, I can just sketch it for you. The horizontal asymptote is going to be y equals 4 over 7. So for this particular problem, here, normally, let's see here. All right. As x is getting bigger, that's the side, x is getting bigger, right? As x is getting bigger, that means that this line is going to get closer and closer to what is our horizontal asymptote? 4 over 7, right? And as x gets smaller and smaller, whoops, I drew this one wrong. This is actually going to go up across here. And it is also, as x is getting smaller here, it is also going towards, it's going to cross there. It is also going towards 4 over 7. But one thing I wasn't paying attention to is it's asking for the right end behavior. So the right end behavior is going to be this side over here. So as it's going towards positive infinity, it is going to positive 4 over 7. And if I have this in the computer as a negative infinity, this needs to be positive infinity. I can't tell if I messed that up or if that when I printed it out, it just looks funny. So be sure to let me know, but if it's the right end behavior, that's as x is going towards positive infinity. Okay. All right, what's the next question? 3. What is the domain of this problem. The domain is going to be everywhere that this equation exists for x. So let's graph this in Desmos. 5 over x minus 14 plus 10. Well, first of all, let's find our asymptotes because that's going to help us. Our vertical asymptote, there's just one. It's going to be x is equal to positive 14. So we have shifted this function to the right 14. That's what that means, right? 14. And we have shifted it up 10, right? And it's gone up 10. And so that means that's going to be the horizontal asymptote is going to be 10. So this function is going to look something like, let's see, if we make our vertical asymptote be 14, so let's say this is x is 14, and let's say this is y is 10, then our function is going to look something like this, right? Cool. What are we trying to find? What is the domain? So the domain is where does this exist on x? So this is going to exist everywhere except at the blue line 14. X cannot be 14. The range, if we wanted to find the range, that would be y cannot be 10. Okay, but for the domain, that's x cannot be 14. Okay, so this was the y, right? And blue was the x. Vertical asymptote, horizontal asymptote. All right. Question 4. This is the one that had a bunch of different questions in there. Hopefully I can get this all in one video. But find the following for the function above. All answers are numbers only. So the first one is, what is the x-intercept? So what makes the output 0? So we could change this to 3 over x plus 4, make it equal to 0, subtract 2 from both sides, 3 over x plus 4. This is where it gets confusing solving these rational functions. I'm just going to cross multiply. So here I have negative 2 times x plus 4 equals 3 times 1 is just 3. Divide both sides by negative 2. And I'm just going to put negative 3 over, 2. If I divide both sides by 2, that becomes negative 3 over 2. And then subtract 4 minus 4. So our x-intercept, or what is going to make this equation 0, is if we do negative 3 over 2 minus 4, which is going to give us, and I can put this in the calculator, but I got to put the fraction in parentheses. Minus 4. Whoops, what did I do wrong? Go to error. Negative, oh, I forgot an entire number. 3. And I get negative 5.5. Okay, so that is what you would put into as your answer there. You could also have put it as a fraction, which would have ended up being, if you go math, change it to fraction, negative 11 over 2. Either one of those would have worked. Okay, so the y-intercept is what can I put in for x, or I'm sorry, what can I put in for y that would make my x 0, right? Or if x is 0, what is y? Right, so what is y? You guys look, that's Mr. Crummel. You can hear him from the hallway. So y equals 3 over 0 plus 4 plus 2. So y equals 3/4 plus 2, or I'm just going to say 2.75, right? So I'll put 2.75 in here. The vertical asymptote, or where does x not exist, right? Where does x not exist is going to be negative 4. So x, don't put an x, I said just the number, right? Negative 4. But you guys, what I can say is that's also going to be my domain, is x is not equal to -4. My horizontal asymptote here is, it goes up 2, right? So basically this is 0, but we've shifted it up 2, so my horizontal asymptote is 2. And you can always graph this too. And y is not equal to 2. So these kind of match, right? My vertical asymptote is what the domain does not equal, and my horizontal asymptote is what the range does not equal. All right, and we can write that in different ways. All right, let's see. This next one is just the same thing. It's just a few more points because we have to factor it first to figure all this out. But first of all, look, these are both degree 2. So my horizontal, and I'm not adding anything over here, right? I'm not adding anything over here. So my horizontal asymptote is going to be y equals, what's the coefficient? 1 divided by 1, which is just 1. So my horizontal asymptote is 1. So let's fill that out really quick since it's easier to find now than when I factor it. So my horizontal asymptote is 1, and that's also going to be what my range cannot be, is 1. Okay, so let's go back up. Let's factor. So the numerator is going to be two numbers that add up to be 2 and multiply together to be -8. How about +4 and -2? So my numerator is going to be x plus 4 times x minus 2. And my denominator, two numbers that add up to be -3 and multiply to be -10, is going to be -5 and +3. Okay, so that means my x-intercepts are going to be +5, because that's what would make that 0. Oh, no, I'm sorry. You guys, I'm finding my my vertical asymptotes. My vertical asymptotes is going to be x is +5, because that's going to make that 0. And my x is going to be -3. So those are my two vertical asymptotes. And these, remember, just from graphing it, if I have something like this, I know that the zeros here are going to be my x-intercepts. So my x-intercepts is going to be -4 and +2. And the reason why is because if I make my numerator 0, that is going to make this whole thing 0, which means y is 0. And when y is 0, that is where my function crosses the x-axis. So we have -4, +2. And my y-intercept is going to be when x is 0. So actually, go back to this one. Go back to the way it was originally. If this x is 0, it cancels out. If this x is 0, that cancels out, cancels out, cancels out. I'm left with -8 over -10, which is actually going to give me +4/5, which is the same as 0.8. And I think I put either one of those in there, 4/5 or 0.8. My vertical asymptotes I found. One is +5, one is -3. Which makes it really easy to figure out x cannot be +5 or -3. Cool. Next, we have a minute and a half to spare. So please make sure you watch this and see what you did wrong in the practice test. And I look forward to seeing you guys tomorrow.